Hi everyone. In this movie, I'd like to give you an overview of the substitution and elimination reactions that we're going to be talking about in class over the next 2 or 3 weeks. So there are two types of each. For substitution, we have the SN1 reaction and the SN2 reaction. For elimination, we have the E1 and the E2 reaction. And so what I want to do is go through one mechanism for each of these just so you have a quick overview. For each of these, I'm going to use the same substrate, bromocyclohexane, because it will work for all four of these reactions depending on the right conditions. So for an E1 reaction, an elimination reaction, we're going to lose HBr, and we're going to form cyclohexene. And the standard conditions for E2 are heat is the main thing, and then often some sort of alcohol solvent. So let's use methanol here. All right, let's go through the mechanism. So the first thing that happens in an E1 reaction is the leaving group leaves and you form a carbocation. So we form a secondary carbocation. This carbocation then has a couple protons adjacent to it. And what can happen is the solvent, for example, can come along and pull one of those off. It can act as a Bronsted base. Pluck the proton off, and that that bonding pair of electrons then is what forms the alkene bond. I didn't show it earlier, but we have bromide ion came off, and we lost a proton here. So formally, we have also created HBr. So that's E1. Next, let's go through SN1. You'll recall that SN1 and E1 both happen under the same conditions. So once again, heat and methanol will work as conditions here. But in this case, instead of an alkene, we're going to make an ether, a methyl ether. And HBr will be the other product again. So as before, the first step is the leaving group leaving, creating a carbocation. So we've also created our bromide ion. And now, once again, we use the solvent in this next step. But rather than acting as a Bronsted base and plucking off a proton, the solvent acts as a Lewis base and adds to the carbocation. It's a nucleophile. And so now we get to an intermediate that looks something like this, where we've made an oxygen-carbon bond, and the oxygen now has a formal plus charge on it. And in the final step here, the proton gets plucked off. We could use the Br, we could use the solvent, or we could just show it coming off. And so this OH bond will now become that second lone pair on oxygen. So there's SN1. Next, let's talk about E2. So these last two mechanisms are only one-step mechanisms. So again, this is an elimination reaction, so we're going to create an alkene. So there's our alkene cyclohexene. Why don't I draw these hydrogens in just so it's easier to see what's going on here. So that carbon has a hydrogen, and then this carbon has two hydrogens. In this case, we need some sort of strong base, so we could use methoxide or tert butoxide. Why don't I use tert butoxide? You'd often usually use potassium ion as the counter ion here, but it's a spectator ion, so I'm not going to draw it in. And what happens here is we just use this lone pair, use it as a Bronsted base. It attacks and pulls off one of these neighboring hydrogens. This bond, the CH bond, comes and becomes the CC alkene bond, and in the process of doing so, it kicks off the leaving group. So the products here, in addition to the alkene, are tert-butanol and the bromide ion. So there's your one-step E2 reaction. The last one to talk about is SN2. Here, once again, you need some sort of strong nucleophile, so let's use methoxide this time. This is a substitution reaction, so like before, we're going to create an ether. And the leaving group is the other product, bromide. And like the E2 process, this is a one-step process. So all that happens is the methoxide is a nucleophile. It does a backside attack, so it's going to swing around here, attack the carbon attached to the leaving group. From behind the leaving group, that's going to kick off the leaving group, break the CBr bond here, and there you have it. There's your product, methoxycyclohexane and bromide. So those are your four reactions, E1, E2, SN1, SN2. We'll talk more about all sorts of variations, how to compare them, how to contrast them, how to predict the products, and which one's going to occur under different conditions. So, see you soon.